start.
Time is money.
All right.
Time is money.
All right.
So, a lot of people
Introduce yourself.
were asking a lot of questions about TDS.
Yep.
First of all, I would like to introduce myself. I'm called Barista Erkman. Barista Erkman. Stroke, barista
Wine.
trainer, roaster, whatever.
Anything
Stroke or coffee.
anything concerning with coffee.
Yeah, anything concerning with
I'm
coffee.
Ronald. My TikTok, I use MRC as usual.
Yes.
A coffee lover, a person who has a mood for coffee all the time.
Yes.
So yeah, you are most welcome, our viewers, whoever who is viewing right now. So we are going to be dealing with this today. This topic we have been asked about it for a long time. The use of this. This is this
TDS meter.
So we are going to be talking about it today, and we learn about it so that everyone who is using water or home, restaurant, coffee shops, anywhere, you should know the use of TDS. All right, we can start, my brother.
So this TDS, the one I'm holding here, this one is a bit expensive. This type, the one I'm holding. Why? It's because that this one measures the TDS in water, and it measures also the pH in the water, this one, this type, and it measures the salt capacity in water.
We can say in general it measures the minerals in water.
Yeah, the minerals in water. So, and also this one, it has a mode of measuring all the minerals, potassium and whatever. Because the minerals, we have a lot of minerals. We have inorganic minerals in water and organic. So this one measures organic. It doesn't measure inorganic. The organic it measures is the salt in water. The pH stands for potential of hydrogen. That's what the pH stands for, potential of hydrogen. So it measures also that one. It has the mode. You just change the mode on this one. But not every TDS meter measures all of those things, because most of them, they don't have that mode. I can show you one of them which doesn't have those modes. I have one here, and for it measures only the TDS. Now this one measures only the TDS. It doesn't measure anything else in water. So now we start. First of all, what is a TDS? What is a TDS? This one. What is a TDS? I mean this one. TDS meter is a device used to measure total dissolved solids. Total dissolved solids in a solution, most commonly water. Most commonly water. The reason why I decided to write these things here on a paper on a manila paper like this one, I wanted you, the viewers, to take screenshots so that you can remain with some information, with this information. Or if you can't take screenshot or recording, if you can't record, then you will go to our YouTube channel. This full topic, all of video is going to be there on our YouTube channel. So a TDS meter is a device used to measure total dissolved solids in a solution, most commonly liquid or water. Now, TDS refers to the concentration of dissolved substances like minerals, salts, and metals in water. TDS refers to the concentration of dissolved substances like minerals, salts, and metals in water.
So to add on that before you go further, when we talk about the TDS, as you can see it, let me just use a ruler, it will be better. So he told you that the device they use. So TDS, the total dissolved substances. These substances are the minerals that we mostly find in water that you can't always see
with
with
your
your
naked
eyes.
eyes.
So when you need this to know which water you are taking is either clean or it needs to be purified before you drink it. So you can add.
Okay.
Yep.
Thank you, bro, for that. Now, this meter I'm holding here, or the meters, works by measuring the electrical conductivity of water as dissolved solids increase conductivity. I don't know whether you can understand this statement.
So many might ask, how does that machine test the water and tells you that this water is not clean?
Okay. This machine was designed to detect, the perfect pH in your water. If it is not perfect, the numbers it shows you goes more higher than the expected numbers than the right numbers. We shall reach there on the numbers I'm talking about. Everyone will get to know about the right numbers, but always the right TDS starts from 50, it goes to 150, 50 to 150, then 150 to 250, from 250 to 500, like that. But we are going to reach there. You will get to know everything. Okay? I want us to go slowly by slowly. This water always, it has electrical conductivity in it. That's why this water, when you pump it, even though you're using force to pump it, but the way how it moves, it can move in a wave form. What makes it to move in wave form? Because it has that electrical conductivity in it. For instance, if you go to any waterfall, or where the electricity is being formed from, you see the way how water moves in strong waves, even making sound, which is more and more and more. You feel like something. So that way of water, the way how it moves, it has electrical conductivity in it, or it creates electrical conductivity. That's why in a country like Uganda, we get our electricity from
Hydro.
yes, it's a, we use
Power.
hydro electricity, but we get from
Water.
water,
Falls.
waterfalls, from Jinja. You get the point.
From the dam.
From the dam.
Yeah.
You get the point. So this statement is trying to explain that, to mean to say, to mention that.
Yeah, to add on that, electrical conductivity. Water is one of the most conductive, how can I say, item? No, not item. Conductive, like it conducts electricity very, very, very fast.
Very fast.
So it's like, to give you an example, when you touch in water and you touch on the on wire or a live wire,
it will give you
yeah,
hardly.
even though the live wires touched to the water edge, when you are on a different side and you touch in that water, you feel that electricity. So that's why even this TDS,
Yeah.
it uses that electric wave, which is very, very, very light to detect this dissolved solids in water.
Solids in water.
Yeah.
So now we go ahead. Higher conductivity indicates a higher TDS level, which is often displayed as parts per million. So we count, this statement is trying to inform us or to tell us that the TDS is counted in ppm. That's in short, but in full, parts per million. For example, we count sugar in kilograms.
Mm-hmm.
We count water in liters. We count also like the coffee beans in kilograms as well. There is other things we count in milligrams. So also these TDS measurements, they are being counted in parts per million. In short, ppm. That's why even if I press this one on TDS, you see, I don't know whether you can see this ppm here. And when I change the mode,
You can see it.
and when I change
ppm.
the mode to go to another one, which is pH, is going to show
Parts per.
is going to show the way how we count pH.
Yeah.
If I go to another mode, it shows the way how we count it.
Yeah.
It shows it different.
ppm, those are the units we use to count
The TDS in water.
Yeah. Okay. We can go for.
All right. If you want more examples, it's like in the country where you are, the money which that country uses is counted, let us say, in shillings. Let us say here in Oman, in rials. Let us say in Dubai, they count it in what? You get. So even this TDS is counted in parts per million, which is in short ppm. Okay. Now, here is a more detailed explanation about this. I want us to go slowly by slowly until we shall reach where everyone is waiting for.
Practically.
Practically.
Yeah.
Okay. What it measures, what this machine measures. This machine measures the amount of dissolved substances in water. Water, in short, is H2O. Everyone knows that. Which can affect taste, odor, and appearance. Odor means the smell. Smell means smell. Appearance means the color. The color. So, this TDS meter quantify the amount of dissolved substances in water which can affect taste, odor or smell, and appearance or color. Now, what does TDS mean for water quality? What does TDS mean for water quality? When you want quality, what does this TDS mean for water quality? What does this machine mean for water quality? What does it mean? This machine, what it means for water quality is here. Everything from your water source to your homes, plumbing can affect water quality factors such as taste, odor, which is the smell, and appearance, which is the color. TDS value is a single element in this puzzle, but it's an important one. Here is why is important. Now I'm going to turn, we go to why is important. I hope some people are recording so that you can remain with this information, or you will go to our YouTube channel. This whole video is going to be there. Now, what are dissolved solids?
So dissolved solids. Okay.
You can take them through there.
What are dissolved solids? These ones. Dissolved solids, I can say as it is written, you have ever put salt in a pot of water and to make it boil faster. For this, dissolved solids, those are the solids that can dissolve faster in a liquid, more so in water. As you can put sugar, as you can put salt, as some others, they dissolve. Even there is some metals which dissolve in water. So when you talk about the dissolved solids, we have a lot of unwanted dissolved solids in water that can make it not to be good. So for that, if so, that minerals dissolved before your eyes. If you have ever seen anything like salt, which is more exemplary, it is dissolved very fast. Salt, it is our simple name that we use, but most of the people, they can take it as sodium. So with that, the same thing can happen outside your kitchen. We say kitchen, it's an example, but anything can happen in your system of water, in plumbing, outside your home, coffee shop, restaurant, hotels. So in that process, you can't know the whole story of how water can become in what? Can come the audio to become bad, to see the appearance of water when it's not coming out well, even the taste. When you taste on the water, you are like, this water is not what? Is not nice. So That lead process created materials that can dissolve into the water supplies. These materials can include, we have organic matters, we have calcium, we have magnesium, we have carbonate, we have nitrates and chlorides. So all of these minerals, as you see them, they dissolve in water. So at times when it takes long without you checking your plumbing system, your water system, home, coffee shop, restaurants, you can reach a certain point and you find out when the water is, the appearance is not good, the taste is not good, even the smell is not good. So that one comes in mind. You have to get your TDS and check your water, as we are going to show you in the nearby coming minutes. So when you see a TDS meter or other water testing tools are measuring the total concentration of these dissolved solids in your
Tap
tap
water.
water. So when I say concentration, these minerals, when they get together, they concentrate or they can mix together. So when they concentrate, it's easier for you to test them when you are using a TDS. So here we come. This results in often expressed as per,
Parts per million.
as he has said, ppm. Why does some water have high
TDS level.
TDS? So for that question, we are going to go to the next part. We know why does some water have high TDS levels. So with that, we are going to be turning over. We wrote this one so that everyone can be following. We would have been able to explain it from head, but it is better everyone to see what we are explaining. So we go to that part.
Okay. Now, we are going to reach to everyone where everyone needs. First of all, let me take you through this. Now the numbers are going to start slowly until we reach to the measurements we measure on this live and you see. Now, the last statement, you had it. And now here is, not all water has the same TDS level. Not all water has the same TDS level.
Yeah.
Why? Because it comes from different sources. First of all, here are a few common water sources and their typical TDS levels. Fresh water. This fresh water has less than 500 ppm. Less than 500 ppm. ppm means parts per million.
Parts per million.
And now we have sea water. This fresh water, let us take it as the purified water. Let us take it as the rain water. Rain water and purified water goes under this fresh water. Now, we have also sea water. Water from the sea.
Yeah.
From those
people
oceans.
people
Red
who are
Sea,
near oceans,
Indian Sea.
you can see that type of water. Yeah.
Yes. The Mediterranean Sea, those seas. That one has between 500 and 30,000 million parts per million, ppm. The seawater, when you measure the TDS of seawater, starts from 500 to 30,000 parts per million. And the third type, we have brackish water. This brackish water has between 30 and 40,000 parts per million, which is ppm. This naturally occurring water that is saltier than fresh water, but less salt than seawater. Now, let me explain about this brackish water, because so many people are now confused. Where do we find that brackish water? And is it really there? Brackish water is there. This you've always we found this brackish water where the rivers meets the ocean water or the sea water. Everyone here has ever come across water from rivers, or can have ever come across rivers. So water from rivers is always clean in its color or appearance, very clean. Now, when it comes and it meets together with the water from the sea, this water from the sea, first of all, it has different colors. So when it meets with water from the river, it creates different colors of, it starts from bluish, then from bluish it turns to black, because this fresh water from rivers has mixed together with salty water which is found in the seas or oceans. When they meet together, clean and salty, it starts turning the color from white, or from white to greenish, from greenish to blackish. That's when the water from the river comes and meet water in the ocean. So there is some rivers whereby they come from a distance, from far, but there is a certain part where they meet with water from the seas. You've ever seen that? You've ever seen also some rivers, they come, they pour water in the lakes. Now, like for example, for those people who comes from Uganda, we have a River Nile. River Nile, there is a part where it meets together with water from Lake Victoria, and they join together, then the water goes up to Egypt. That's why Egypt, they are getting water from River Nile, which comes from Uganda, and the electricity. You get now the point. That's just an example. So it's an example of river waters to meet with waters of the sea, and it turns the colors. River water is white, pure white. The sea has different colors because it has salt, and now when it meets with this clean water, it starts turning from whitish to bluish, from bluish to blackish.
Okay.
And now its TDS levels starts from 30 to 40,000 ppm. Why it starts from 30? See, here we said fresh water, because rivers, they have really fresh water and clean.
GX baristas and roasters, St. Roses. We thank you. Thank you so
So
much.
since rivers, they have fresh waters and clean, remember here fresh water is less than 500 parts per million. And now, when we come to the sea, sea has 500 to 30,000 parts per million. So, since this one starts from less than 500, less, so even this 30 is below the 500. That's why this one black starts from 30, and since the sea water starts from 500 to 30,000, now this black sheep, since it has mixed fresh one and the salty water from sea, for sure its TDS has to rise more than these two, because these two has met and they have mixed. You get the point now?
Yeah.
Okay, we go ahead. Now, how this TDS works? TDS meters pass a small electrical current through the water sample.
Yep.
Through the water sample. Now see, here we have water samples. This one in this glass is tap water. In this glass is tap water.
Yeah.
It's now a water sample. This one in this glass is purified water. Purified water, this one was purified, or it has been purified by reverse osmosis system. Reverse osmosis system, which means that is very clean and is very good for drinking.
Ready to drink.
These are water samples. We are going to reach on these. Let me first put them down. So those are water samples. That's why they are saying here that TDS meters pass a small electrical current through the water sample. Through the water sample. The amount of dissolved solids affects how well the water conducts electricity.
Okay.
More dissolved solids means higher conductivity, and thus a higher TDS reading. Now, here we go. We are going to use these samples to demonstrate this statement. Maybe I repeat for you the statement, and we measure now the samples we have today. Now, it's saying that TDS meters pass a small electrical current through the water sample. The amount of dissolved solids affects how well the water conducts electricity. More dissolved solids means higher conductivity, and thus a higher TDS reading. Now, let us measure this right now, because we have the water samples. Now, this is purified water, purified by reverse osmosis system. And this water is good for drinking, is good for coffee machines. Now, let us measure the ppm for this water.
So you can see right now. I think you can see it. It is on 0 ppm, as you can see. 0 ppm.
Parts per
million. It is on 0 now. So
now,
you can go ahead.
Since it is on 0, this is a purified water. Purified water, we use the reverse osmosis system. Now,
Come nearer.
I come near. Okay. Okay. So this one, first remove,
Can you see?
then you hold. It's showing how many?
60.
60.
Yeah.
Yes. This one, purified water, is showing 50. What?
60.
60.
Not seeing. They're saying
Not seeing.
not seeing. So
Okay,
put on the
let
right.
us repeat it so that it can show light very well
Let me put
for them to
forehead
see.
as we're explaining it. So you are seeing it now. It's on 0. This is the water, purified water. Ah, you have seen? As you can see, this is the water which is
Purified, and
purified.
is good for drinking, good for your coffee machine. Now,
Yeah.
water, to measure or to know that this TDS which is in my water is good for drinking, good for coffee machine, always we start from 50 ppm to 250 ppm. But on some circumstances, 250 exactly, sometimes it can it can taste salty, slightly salty, or it can have more acids. So when it reaches 250 exactly, that one is not really nice. Is good, but is not really nice
Nice.
for your coffee when it reaches 250 exactly. So it's good to be between 150 to 150, and from 150 to between 250, just between, not exactly 250. When it reaches exactly 250, it tends, or it starts, or it slightly start to taste salty, and it starts to have odor or smell. You get the point? So that one, when it reaches 250, when you measure your TDS and it's 250 exactly, immediately change your filters immediately, because that water, it's going to affect your coffee. If you are using the 250 TDS on your coffee machine, the water, you have to change
Filters.
the filters for that system you're using, whether reverse osmosis system, you have to change them. Even if you are drinking it at home, when you have that reverse osmosis system, please change the filters immediately, because that water, when it reaches 250, these are the things it can cause to your body, because it starts now to become harmful to your body. First of all, it can cause you vomiting. Everyone here, or some of you here, you've ever taken water, then after drinking that water, you feel like you want to vomit, and finally you vomit. And for you, you can think that maybe you have malaria or something else, when you know that water has a problem and the water has caused that. Also, that water causes what we call sleepiness. Sleepiness. when I say sleepiness, you can even go to bed, you reach there, you fail to sleep. Thirdly, what it can affect you, that water, when the TDS is starting from 250 going up ahead or above, it can cause you some you become you start feeling fatigue. You start feeling fatigue, like as if they have beaten you, like as if they have like as if they have broken your muscles. You feel there is a way how you feel. You feel fatigue in your body,
Feeling dizzy.
dizzy. So it comes from that water, because the TDS has now started becoming abnormal for your body. The TDS in that water. Another thing, what it causes to your body is always you start to forget. You start forgetting things. You can be with your phone. Let us assume that this is my phone. I can be with my phone in the hands, and then I start looking for my phone. Even I can ask my friends, hey, man, have you seen my phone? My phone has got lost. Please, can you try to call on my phone? Please, please. When you are holding it, when you are holding it, so when you take water, and that water, its TDS starts from 250 and above, you start experiencing such unhealthy conditions on your body. So always be very keen. Even if it's at home, please take care of these things. Please. Even if it's in hospital, hotels, restaurants, coffee shops, please be very keen. Always be with a TDS which measures the TDS in your water, which measures your water's parts per million.
Yeah.
Now, we are still on this. We've measured the purified water. Now, we need to measure the tap water. This tap water is going to show this statement.
The amount
The
of dissolved
solids affects
affects
how well the water conducts electricity. More dissolved solids means higher conductivity,
That's the
and
higher
thus a higher TDS reading.
okay.
This is tap water from tap.
Tap water. So now, as we can see, on is on 0. So I'm going to dip it into the glass. So you can read for me. What are you seeing? 405, 408 ppm.
Now, leave it there.
As you can see, 400. So
now, it's already 400. That's the tap water. But they are telling us here that more dissolved solids means higher conductivity, and thus a higher TDS reading. Now, more dissolved solids. Now, I have salt here. I have salt here. We are going to demonstrate. Now, there it's showing 400 something.
408. So we are going to add in salt, and we see.
And you're going to see, because the other tap water is already giving 400 something TDS, which is really harmful. And now when you add in salt, which is going to mean more dissolved solids, means a higher conductivity and thus higher TDS levels. So we are going to add in another dissolved solid which dissolves in water. We need to put the TDS there, then I pour. It's going to here. Okay. This is salt. I think they can see. This is salt. I'm adding in this water.
Yeah, they can say, I think. Now, dissolving, we are going to mix it to dissolve. As we are mixing it to dissolve. It has dissolved very well and tasty. The taste, as you can see. So now, we are going to put in a TDS and we see how it will look like. This is our water. This is our TDS. So we are putting it on.
You're seeing the way how it's running, the figures.
Wait, the mode has changed. Let me change the mode. Here it's measuring temperature and what?
Oh, because this one measures the temperature in water, the pH, the salt,
I'm showing you
the
there.
TDS. This one measures a lot of things in the water. You just change the mode. That's why this TDS is very
pH
expensive.
Is 7.5.
You need to first clean it very well, like this. And you put it in the right mode for TDS.
pH 7. So now
It's now reading how many? Because I know it's still running, counting.
it has even changed. It is PPT.
Because it's more than.
It's more. It is in 500 plus.
It has changed from TDS. It is in 3,000.
Let me show you. I think you can see it. Let me show it to you. It is on 0. You can see. Now you see. It hits 20,000.
It hits 20,000.
20,000.
That means that
it changes to PPT.
PPT. PPT means parts per salt in the water.
Parts per trillion.
I mean per trillion, not salt. Per trillion in the water.
That
now
increases from more than. So parts per trillion.
That
PPT.
one takes us to
This one.
Takes us to this statement, which is reading more dissolved solids means higher conductivity and thus a higher TDS reading.
Yeah. So it's more. Very, very, very high.
Very high. Now, this one takes us to baristas, head baristas. It takes us to your coffee machines. When calcium becomes more in the water which is in your coffee machine, there is that valve. I don't have a sample here of that valve. I would have shown you here. There is a valve where water passes through and it comes to your group head of your machine, to the group head of your machine. That valve, when calcium becomes much in water, that valve starts to become blocked slowly by calcium, which is salt. That means that your filters, you forgot to change them for a certain period of time, for a good period of time, and now they can't filtrate your water to the right TDS or to the right parts per million
resulting in too bad taste of
of
coffee.
coffee.
Guys, tap on your screen,
Even the
share.
valves where water passes through from the boiler coming up to that valve which allows again that water, because that valve which allows water to come to the group head, it has a magnet. It keeps on rotating like a disc. When it rotates, it beats the water to move to come to the group head. But when it becomes saltier, or when calcium becomes more on that valve, it can't rotate properly and it can't move that water to come to group head. Even those valves from the boiler, when they start becoming blocked with that calcium from water, they can't also move that water from boiler to the group head. Even the boilers, when they become more covered with calcium inside there, then you start getting less water here in the group head. The water which starts coming out is less.
It will be drizzling.
Just it will be drizzling, but the problem is coming from either the boiler or the valves. That's why we always say that every after 6 months, you have to do what we call
Full service.
full machine service. And after some years, or 2 years, or 3 years, or 4 years, or 5 years, some machines, they get blocked in the boilers. What they do, they take those boilers, they cut them, and they wash them. After, they leave them with nitrogen, whatever, fire, whatever. But now there is technology which has just come recently. There is no need now to cut those boilers. They just use the holes of these valves where the water passes from the boiler to the group head. They remove the valves. They use those holes. Then there is a pipe they use. They mix water in a certain bucket or whatever. They use some force to pump that water inside the boiler, and the water has good chemicals which washes or cleans the boiler. So that technology has just come also. There is no need to cut the boiler. Then you clean. After cleaning, they get that nitrogen and whatever, they start limiting it with fire. No need now. Now let us proceed. Why is it that this TDS meter is useful? Why? Now, checking water purification systems. That's number one. Checking water purification systems. TDS meters can help verify the effectiveness of water purification system, like reverse osmosis system, by showing the reduction in dissolved solids. So we use these TDS meters to verify the effectiveness of water purification systems like reverse osmosis systems by showing the reduction in dissolved solids.
Yeah, let's go.
So this statement takes us to when you change your filters on your osmosis or reverse osmosis system. When you, after changing, you measure the TDS of that water. Of course, it will start from low, from 30 maybe, let us say, but from 50 or 40, it will go on climbing up, rising up to the right TDS. Now, another reason why it's useful, why this TDS is useful, is assessing water quality. Assessing water quality. TDS levels can indicate the overall quality of drinking water, with higher levels potentially affecting taste and potentially indicating the presence of unwanted substances. First of all, what I would like you to know is that this TDS can measure minerals in the water, but there are some inorganic substances which it doesn't measure. The likes of lead, it doesn't measure lead in water. It doesn't measure uh, uh, lead, and also I'm forgetting others, but when I remember, I will inform you. I will inform you. But another reason why this TDS is useful is aquaculture and hydroponics. Aquaculture and hydroponics. Now, TDS meters are used to monitor nutrient levels in aquaculture and hydroponics systems. Now, here the farmers come in. We said everyone uses water. We said hospitals, they use water. Lodges, they use water. Hotels, coffee shops, everywhere. Now, farmers, you are here on this aquaculture and hydroponics. Now, aquaculture means all of you here, you know those aquariums. You find there different types of fish. Those fish, they eat them. They don't keep them there forever and forever. They keep on changing them. They eat others. But that water of aquariums, they first measure that water, the TDS of that water, and the pH of that water. I said pH stands for potential and hydro, and I said potential and hydrogen. Now, this water, when it's on the right TDS, it has nutrients, and it adds nutrient levels in that water, even though they always add in these artificial nutrients, but that water itself, it adds nutrients in those aquariums. And now, farmers here who does hydroponic foders, farmers who use hydroponic foders. Hydroponic foders, farmers who are here on this live, they can testify. When you get those trays, you can get even any tray. You plant either rice seeds or maize seeds or millet seeds, any type of seeds, and you first soak them in water for few hours, then you remove from water, you put them on those hydroponic powder trays or any tray. You keep on every day
Watering them.
spraying water on top of those seeds. But that water you spray on those seeds is always either rainy water or water which was dug from ground, from the well. Why do you always use such kind of water? Reason being that that water has good pH, has nutrients in it. If you use water from tap water, that water comes from water and sewerage corporation, which means that that water is mixed with
Chlorine.
chemicals, which is chlorine mixed with a chemical called PFAS.
Yeah.
I don't know whether you don't know. I don't know whether you know that what it means, but I will tell you what it means. Let us go on. Now, these farmers who use hydroponic fodders, they use rainy water to spray on their seeds in order those seeds to grow and they give their birds or animals. And always the hydroponic fodder for chicken, they always keep it or it grows within 4 days and they give chicken by the help of that water, rainy water or water from the well, dug from the ground. When they grow hydroponic fodders and it goes to 7 or 8 days, that one they just give goats. They don't give it to chicken because it has overgrown, which means that the nutrients has developed more and more, whereby it can even cause some diseases to chicken. So when they grow again hydroponic fodders and they go to 10 days, those ones they give to cows and the other animals I won't mention here. So farmers, this is your statement. This is where you fall. This is where you lie in aquaculture and hydroponics. Always you use water with good TDS, rainy water or underground water. So you see that this TDS in water covers everyone.
Covers everywhere.
Everywhere.
Yeah.
Now, what it doesn't measure, that's what I was talking about.
They have to understand that.
This TDS, there are some substances it doesn't measure in water. Now, why useful? Why this TDS useful? TDS meters don't identify what is dissolved in the water, only the total amount
of dissolved minerals.
It doesn't tell you that salt is in this water, nitrates is in this water, this is in this water, but it just tells you the amount of salt in the water, the amount of nitrate in the water only. Now, they cannot detect specific contaminants like
It looks like that.
the TDS, they cannot detect specific contaminants like lead, pesticides, or bacteria. The TDS meter can't detect these substances,
Cannot detect lead,
lead,
pesticide, or bacteria.
pesticides, or bacteria.
Yeah.
For detailed information about specific contaminants, a comprehensive water test is
It's
necessary.
necessary.
This statement tells you what? That when you start feeling the other things I said, that when the TDS starts from 250 and above, then you take that water, you start feeling a lot of headache, you start vomiting after drinking that water, you start feeling dizzy,
Yeah.
you start forgetting the things,
You get amnesia.
you get amnesia. It means that that water has lead in it, has pesticides in it, or bacteria in it. Now, here, for detailed information about specific contaminants, a comprehensive water test is necessary. It means that you have to test your water to know what is really affecting my water.
So that one will need
another meter which
that
is
can
specifically
can identify the minerals in water.
which can identify these things in water, these substances in water. Those meters are there. Those meters are there. If you don't know them, do research. Those ones I'm not going to tell you here, because I don't want to spoon feed you. I don't want to put everything on your finger clips. You get? Do research. Now, we go. We have limitations. TDS meters are not designed to detect harmful contaminants like lead, PFAS, the one I mentioned there, that chemical is always in the water, and also chlorine. But don't forget this chemical, PFAS,
it is like a preservative that
is a preservative,
yeah,
as like my brother is saying. This PFAS is always in every dish
food,
which is packed in containers,
or packed foods that
like the baked beans. If you eat a lot of baked beans,
chicken,
those baked chicken, baked fish, those baked meat, in those ones,
tinned one,
or tinned ones,
yeah,
this PFAS is always inclusive in those foods you eat, because it's the one which keeps them to last for long time. Yes.
However, it is bad on the side of our health.
Yes, it's harmful on the sides of our health. If you eat a lot of those things, in the nearby future, you start suffering from cancer. Suffering from this one is, they call it what? Prostate cancer, and a lot of diseases. Then you start saying, where did I got cancer? It comes from this one, PFAS.
Yeah.
This PFAS stands for per and polyfluoroalkyl yeah,
Polyfluorelic
fluororic substances. I don't want to bite my tongue now. I have a lot of things to do.
Too much chemistry here.
Yes. It's
Okay.
too much chemistry, physics, biology, and mathematics. Don't forget that.
So they can do more research about it and they understand about that. But that chemical, it was formed in 1940.
Yeah, by some
Scientists.
some
They were
scientists
trying
it was in Canada.
to discover
Canada,
something
yeah.
that can preserve the food that they pack for the soldiers who are going in war.
In wars, yes.
So that one,
This,
that's when it was formed.
yeah, it was
It is a
started in
preservative, but
1740.
it is harmful to health. So that is it. You can go on.
Okay. So we said TDS meters are not designed to detect harmful contaminants like lead, PFAS, or bacteria. Now, they are primarily useful for assessing the overall mineral content and the effectiveness of certain water treatment methods.
Yeah, I think everyone is getting it, guys. Please tap in the screen, like our videos, comment, and share it.
Also, our YouTube channel.
You can subscribe to our
Please
YouTube
go
channel
and subscribe on our YouTube channel.
So you can comment yes if you are understanding what we are talking about or about TDS. Yeah, you can go on.
Our YouTube channel is called at Coffee House at Large, and it's the same name we use on our TikTok page at Coffee House at Large. And the link is in the bio. Click in that link. It will definitely take you to our YouTube channel, and please subscribe. After subscribing, don't forget one thing. Click on the notification bell so that whenever we upload any video, whenever we go live on YouTube, you will be notified. That one is clear. We proceed.
Yeah.
So, how to calculate TDS in water? How to calculate TDS in water? How to calculate TDS in water?
We would have calculated for you. Okay, you can tell them the example, but we would have calculated for them one of it, but
one of okay.
We are running low here. So
we are running low. Yeah. Okay, let us just I will just explain to them the way how they can understand it.
Yeah, yeah.
Okay. In the water, when we measure TDS water, we have the rejection numbers. Those rejection numbers starts from 20 to 30 to 40 up to 49. The right TDS starts from 50. Don't forget that. The right TDS in water starts from 50 to 150, then from 150 to 250. So the rejection amount of TDS starts from, let us say, 0, 10, 20, 30, 40, 49. Now, we are going to use, here, we are going to use 20 as the rejection. So, tap water, like the tap water we measured here, tap water, TDS, minus RO TDS. RO means reverse osmosis. The reverse osmosis we use to purify our water or to filtrate our water. Everyone knows that reverse osmosis system we use to filtrate our water, whether coffee machine water, whether home drinking water, hospital drinking water, like that. Everyone knows that one. So RO stands for reverse osmosis system. So tap water TDS minus reverse osmosis system TDS times 100, because when our TDS starts from 50 and it goes up 100, then we start counting that the water is really good for drinking. Then from 100 to 150, from 150 to 250, like that. So we times by 100 over tap water TDS, over tap water TDS. Now, for example, tap water TDS, we assume that it's 260 ppm. This is just assuming. It's just an example. Even though our tap water here, when we measured the TDS in it, it started from 480 something. You get? But here, okay, you can put that 486 here, but here we are just assuming that it's 260 ppm, which is parts per million, and we have reverse osmosis system TDS, which is 20, the rejection 20, which is the rejection ppm. This one means that the 20 is totally low. The TDS is totally low, low and low and low, which is rejection. We assume that is, we count 20. As the wife said, we can start counting it from 0, 10, 20, 30, 40 up to 49. Because the good TDS starts from 50 and above, up to 250. Now, we count reverse osmosis system, 20 ppm. Now, rejection, we get the TDS of the tap water, which is 260. We are assuming that is 250, 260, minus the rejection water for our reverse osmosis system, which is 20. 260 minus 20, or let us assume that here we have 486 we measured there. You get? So here, this is an example. We are assuming that is 260 minus 20, which is the rejection of our reverse osmosis system. Divide by 260. 260 minus 20. Divide by 260 times 100. This 100 I said up here. Now, 260 minus 20, the balance is 240. Now 240 divided by 260. Anyone who has a calculator there, you can calculate this on other phone. You can calculate this. 240 divided by 60, you get 0.923 times 100. Our 100 here.
So we get a result of 0.923 times 100.
Times 100.
Which gives us
92.3. 92.3. This one is very nice water for drinking, nice water for using to cook. Nice, this TDS, 92.3 is good for your coffee machine, is good for everything. This TDS. Even if we do 486 we counted there. It means that here the rejection TDS of our reverse osmosis, instead of making it 20, we can make it 40.
Guys, have you gone to sleep because of the calculations? Huh?
We can make it 40, and you calculate also, you will get a good number TDS, which is good for water drinking, for coffee machine, like that. Now, we have here taste and smell. Taste and smell, that one, we found it in tap water, a high concentration of total dissolved solids.
Can have a bitter.
Can have a bitter taste and unpleasant smell. That's the tap water.
Yeah.
The higher the concentration of total dissolved solids, the more bitter your water will taste.
Yeah.
Now, we've finished the tap water. Now, reverse osmosis system and a ceramic water filter are both recommended to improve the taste and smell of bitter tap water. Because the water, this reverse osmosis system does filtrate, is always tap water. The water we measured here, which was 486, is tap water. So is the one which goes to this reverse osmosis system, and it filtrate it, it purify it, then it becomes good for us to drink and to use in coffee and other things. Why should you measure total dissolved solids? Total dissolved solids can affect your water quality, your health, your home plumbing system, and even daily tasks such as cooking and cleaning. This statement tells us that, actually takes us back to the statement I said that when the TDS is high or starts from 250 and above, it will cause health problems to you. So here they are telling you that total dissolved solids can affect your water quality, your health, your home plumbing system, and even daily tasks such as cooking and cleaning. So it affects your health and other items, other things. By measuring your water for TDS, you can better understand your water quality, how it affects your everyday life, allowing you to make an informed decision to solve your water quality problems and install the most effective filtration for your home. I hope those who are watching this live today, they are getting some information they didn't know about the water, where they are working, where they are staying. So I hope you've understood everything. And if you have any question, you can type it there. You can type your